So welcome to Seen and Solved. I'm your host, Tim Pennington. Joining us today is Mike Valenti, our go-to guy for cleaning that matters. When it comes to getting parts truly clean, Mike knows what works, what doesn't work, and why the right equipment setup can make all the difference. Stay with us. We'll be right back.
This is Molly Kellogg, President and CEO of Hubbard-Hall, and this is our podcast, Seen and Solved. In each episode, we will share practical solutions to complex surface finishing problems. Let's listen in to the latest episode.
So, Mike, thanks for joining us today. I know you've been in this cleaning industry for how many years now? How many years have we coming up on this? How many decades?
For metal finishing, 12 or 13. I had some other cleaning experience in a different industry in a prior life.
People know Hubbard-Hall for chemistry and getting that all right for people. Let's talk equipment today. One thing I was going to ask you about the role of equipment selection in getting very good cleaning results. How important is that? I know you've seen a lot. Tell us about that. How important is that equipment?
It's really important. So, it's funny is I get phone calls all the time for people who have cleaning problems, and they say, well, if we just switch out the cleaner, it's going to fix the problem. And what I find out is probably 85% of the time, it's not the cleaner that's the problem. It's the equipment that's the problem. So, equipment is just as important as in chemistry. I tell people chemistry can't solve every problem, right? It's synergistic. You've got to have the right equipment and the right chemistry to do not just cleaning, but anything in metal finishing. So we see this on a repeated basis where they think if they change the chemistry, it's going to make a problem go away. So equipment is just or sometimes actually more important than the chemistry itself.
Is it wrong equipment or them not using it properly?
It can be a number of things. It can be the wrong equipment. It can be throughput problems. They haven't, they've outgrown the equipment such that they can't run a number of parts. They've tripled their ability to run parts, but they haven't upgraded the equipment, right? It can be a maintenance issue where the equipment just hasn't been maintained properly for many years, sometimes decades, and now the equipment's starting to almost fail on them. So it can be a number of things. The not having enough tanks, changing the types of parts they run. Something as simple as going from steel to aluminum. Now I don't necessarily have enough tanks. I don't have enough rinse tanks to do proper rinsing. So it can be a number of factors, but generally it's because, changing chemistry is relatively inexpensive, but putting in new equipment is a huge capital cost. So people are going to avoid that if they can do it, right? They're going to try to get as much life out of that equipment as they can. So it's all it's all the above. Yes, it's all the above.
Let's talk about the different, the basic differences between it. We got ultrasonics, spray under immersion. We got agitation cleaning. Talk about those. What are the differences between all those processes?
So, you've got, basic immersion cleaning where the parts are just going into a solution and they're sitting in the solution, and the parts can be on a rack. They can be in a barrel, and you're just using, some type of agitation, and you're just using the chemistry itself to remove the soil from the surface of the parts, right? And that's really good if you have a lot of time to clean the parts, right? So, for example, a big barrel phosphate line where you're doing, 5, 10,000, whatever fasteners at a time, you're running them in a barrel, and, that's a good way to clean, immersion cleaning in a barrel, right? But let's say you're powder coating, and you've got to powder coat, 10,000 pieces a day. So you're running those parts through a spray system. Well, you can't immerse all those parts, right? It's not efficient. So, and you're going to spray clean those parts as part of the entire system. So you're going to clean them, pre-treat them, dry them, and then paint them real time, right? Sonics is just an add-on technology that helps cleaning. It creates something called cavitation in the solution, which basically causes bubbles, if you want to describe them, to implode inside the cleaner to create an implosion or a jet that'll hit the surface of the part. And Sonics are good for removing things like particulates and solids that adhere to the surface of parts. So all these technologies have to be applied to the right application. And you look at, there's new systems out there that do all three. You see all these, everybody's moving to these chamber type washer systems. There's a number of companies that make them where the parts are flooded, they get spray, they get sonics, they get all these technologies depending on the type of part. So all these things are important when you spec your cleaning process at the beginning, right? A lot of people will make the wrong choice, or like I said, they'll, like, especially a job shop. Job shop will take a new job and then realize, we don't have the right cleaning equipment to do the clean. They've got all the rest of it, the plating, the anodine, whatever they're doing, they've got that. They may not have the right cleaning solution. I've probably, in the last 2 weeks, probably talked to 3 different new prospects that their problem is not their cleaner, it's their equipment is not capable of handling what it is they're trying to do.
And so a lot of that is part geometry, right? I mean, not all parts are the same. You got downhole.
Part geometry is a big issue. It's really becoming an issue now with all solvent regulation, where, parts that have intricate geometries, blind holes, recess areas, you solvent degrease those, the vapor gets into all those little nooks and crannies, cleans them all right. As people want to move to aqueous cleaning from solvent cleaning, now that becomes a bigger problem because the surface tension of water is so high that it's hard to get inside of all those little areas. So, but there are equipment companies that are with some newer technologies out there that are trying to innovate around that problem. But yes, complex geometries and aqueous cleaning has always been a problem. What we're seeing now is people wanting to get off solvents completely, going to aqueous cleaning. This is a much bigger problem, and it absolutely requires equipment changes.
It almost takes like a step back and reevaluate everything, right? I mean, it seems like you can't go with any assumptions that everything's going to work, because it's just not. So when you walk into a plant, like you said, people that where the equipment may not be working, when you walk into a plant, what are some clues that tell you that you're going to see a problem here? There's going to be a problem. It's not going to work correctly.
Yeah, there's a lot of different things. If I go into a facility and see, number one, I can look at the cleaner tanks and I'll ask them, first thing is, how often do you have to change this tank? If they tell me every 3 days, then that's your first indication, right? They've got so much soil going into the tank. And then the second thing is I like to look at rinse tanks, because the thing that people skimp for some reason the most on, and they're the cheapest tanks, is rinses. And I can look at a rinse tank and see how clean the rinses are sometimes, and immediately know if they're putting too much soil load through a system, right? Because, and I get it. The problem is that people are trying to reduce the amount of water that they use, because for treatment purposes and waste purposes, right? But I always tell people, however many rinse tanks you think you need, multiply it times 3. What happens generally is somebody will be getting the parts clean and they'll drag all the dirty, cleaner gunk into the rinses, and they'll just redeposit the soils right back on the parts. So, an undersized, the other thing I can usually look at a system, especially as aqueous, and tell if it's undersized for the amount. I mean, I'll ask, how many parts or pounds of parts you run in per day? And then you look at the size of the cleaning system and you're like, there's no way you're going to continue to clean parts without changing these tanks out all the time, right? And so, and it's becoming a bigger and bigger problem, because what I've noticed is less and less of the, so if you're a job shop and you're getting parts in, a lot of times, a lot of places would pre-clean those parts, at least partially for you. Now we're seeing more and more parts come in that nobody's doing any pre-cleaning. So not only you're getting all the oil and stuff coming into your shop. So now you have dirtier parts than you used to have. I'm seeing it with aluminum more than anything else. I think it's because of the source of the aluminum, where it's coming from, that we're seeing more and more aluminum that's much dirtier than it used to be. And most aluminum lines aren't set up to handle heavy soil loads. So yeah. So, but yeah, you can generally just tell by looking at the tanks, asking the operators how long is it, how many days does this cleaner last, and looking at the rinses, you can kind of generally tell. And of course, the other key indicators, if you see oil in tanks down the line, if you see oil sheen on a plating tank or an acid salt tank or something, there's a problem.
With you all being sort of, heavily involved in the chemistry aspect of it, how does that, the chemistry choice go into, equipment design and the setup? I mean, I'm sure it's all got to kind of work together. The right chemistry is not going to work on the wrong equipment and vice versa, right?
So we'll go into a place, let's just say, somebody will say, hey, I heard that there are cleaners that will displace the oils so we can constantly skim the oil off and keep the bath clean. And I'll say, yeah, we have those. And then you go look at their equipment and they have no oil, they have no weir, they have no way to skim the oil. So if the tank is not set up, if there's no oil separator, if there's no coalescer system, they're not going to be able to run that type of system, right? So they would need a cleaner that just emulsified the oil. So, and then we have some people that'll say, well, I want an emulsified system, right? But then they'll tell me, but I got no waste treatment, so I can't dump it. Can I dump it down the drain? And I'll say, no, you can't dump it down the drain. So then they got to pump the tank out. So, we have lots of different types of cleaners. But the issue always is the system designed to run that cleaner? So for example, great example are spray systems, right? So all spray cleaners are generally formulated to split or displace oils, right? Because you don't want to spray emulsified oil inside a spray chamber. So I'll go into a place, I'll have a big spray system. I've literally had people that the coalescer systems that come with those spray units, they will not install them because it's more complex. And I'll say, you've got to have a separator in your spray line, because if you don't, how are you getting the oil out? And you'll look inside the tank and there will be literally just half an inch of oil floating on the top. And I'll say, you've got to have a separator. So, what we try to do, and I try to do when I go into places, look at and say, even if they want a certain type of product, I'll say, no, you need this type of product, because unless you modify your equipment, you're going to have this problem, right? So, yeah, so it's a big issue. Sonics, a lot of times we will see parts that need sonics, but they don't have it, and that's a big capital upgrade a lot of times to go in and retrofit tanks with sonics. And people say, but isn't there a different way? And I'll be honest with them and say, I don't think there's a different way. You need to talk to somebody about putting sonics in. We're working with a company right now running aluminum, and years ago they built it's a powder coat system, okay? And whoever built that system told them, oh, you can get away with 4 stages. Well, that's years ago when they were running different chemistries. Now they're doing zirconium, and somebody told them they could do a etch clean in their same system. Well, they can't. They're failing because they actually need a 6-stage system. We're the 3rd supplier they've talked to, and I think we've all told them the same thing. They've got to put a cleaning stage on the front of the line, or they're never going to get good parts. And they don't want to hear that, because somebody at some point told them that this system would be, and it might have been good 15 years ago when they built it, but not today. And then they said, well, yeah, our aluminum supplier changed a couple of years ago. We've had problems ever since. So the lubes changed, the surface of the parts changed, and now they're in a situation where they think, like, there's got to be a product that works. And I'm like, well, we don't have one. The 2 competitors you brought in didn't have one. So you need to pre-clean the parts. And it's funny. The answer was, well, that's going to kill our productivity. I'm like, well, you're making bad parts now. So I get it. I understand their frustrations, and I sympathize with them, because putting on a capital piece of equipment, it could be 6 months before they could be able to get that fixed. So, but it's this kind of mindset that, well, all we got to do is throw chemistry in there and it'll fix the problem. And that's just not the case anymore.
You were talking about, with spray. Uh, how can the agitation spray patterns, those can be adjusted a little bit, right?
That's another thing we see a lot of times when you go into what a spray system is. The nozzles aren't set correctly, so the nozzles are in the wrong direction. The pressure isn't right. I tell people, higher pressure is not always better. Sometimes you need to flood the parts with solution. Not if you have too much impingement, you'll just bounce the cleaner right off one surface, and you only clean half the surface of the part. So, the angle of the nozzles, the pressure, how much chemistry, what soil are you removing, how much time do you have in that cleaning stage, all those factors have a lot more to do with the parts getting clean than necessarily the cleaner. Because a lot of times we're only got 30 seconds, right, to a minute in some of those stages to clean parts. So heat, all the standard variables are important in how the equipment is set up. So yeah, it's all those mechanical factors are just as important as the chemistry.
I don't think I've ever been in a shop and met somebody who was in charge of cleaning or pre-treatment or whatever it be.
Unless they have a pre-cleaning site. So some places, you usually see that in captive shops, where you'll have a captive shop that's doing everything. They're making parts for their in use, and they've got, say, a stamping department and a cleaning department, and then the parts may go get anodized or something, right? And the parts it's all captive. They're all doing it for their own internal, right? But in job shops, generally, no. They've just got somebody. A lot of times it's the maintenance guy. He's in charge of the cleaner tank, right? And my favorite thing is, well, Mike, it's just soap. Can't we just put a different soap in there? I hear that all the time. Yeah, it's hard. I mean, that's why we try to go in and educate people in, because if the parts aren't clean, nothing else you do is going to matter.
What are some of the main maintenance calibration steps that just aren't getting done? Like you said, is that checking pressures, checking angles, those type of things, or any others that?
Yeah, in the spray line, it's generally the wrong pressure. Are you getting contact with, are you getting spray to contact the parts? I mean, I'll go in, somebody will say, we got water break in the bottom of the part. And I'll say, we got water break there because you don't have any good solution contact there, right? So, adjusting and the other big maintenance issue with spray systems is just shutting them down and occasionally cleaning them. Those nozzles get clogged. And when they get clogged, they don't spray properly. So people will run these systems and just run them to death and never shut down and do any preventive maintenance. And once the nozzles and the risers get clogged, then, they're just dribbling solution out. They're not hitting the part. So, the configuration, depending on the parts, a lot of people don't have enough risers or don't have, I like to see the halos, depending on the parts. So, and then rinsing in those systems, a lot of times the rinses aren't correct either coming out of the cleaner stage. So, and again, it's nozzle configuration, pressure, and the type of nozzle. Like I said, the type of nozzle. Are you getting a sharp spray pattern, or are you getting a more dispersed pattern, or a flood? All those things depend on what you're removing, the type of chemistry in a tank, and how much time and temperature. So all these things go together. It's not just the cleaner.
People want to talk about, automation and, modern controls and things, and some of them, can help, but how's that changed your thinking about equipment today?
We do. Automation is helping a lot. There are a lot of automated ways now to monitor things inside the tank. There's also tools you can use to measure the parts to help you understand whether you're getting clean parts or not. So there's a lot of technology available but that technology, again, it's a capital expenditure, and it's the same struggle. People, struggle more spending the money to put equipment in. But there's lots of ways we can teach and coach people how to monitor cleaner baths. You can't just go out and do a titration anymore and say, well, I titrated, my cleaner concentration is 10%, so I must be okay. There's lots of other technology available today, sensors you can put in tanks, inline monitoring. One of the biggest problems I see is people keeping their concentration constant, and there are really simple feeding methods to feed the chemistry into the tanks so that you take the operator error out of the equation, and keep things more consistent. And there's some very inexpensive ways to do that. But you still have a lot of places where people are literally weighing up cleaner in 5-gallon buckets and saying, well, once a shift, we dump a 5-gallon bucket in there. And people buying newer equipment, some of the newer equipment now comes with a lot of that monitoring capability included. Upgrading is generally the issue. People need to upgrade their equipment.
When you're talking about cost, like you said, and I'm sure having the wrong equipment running and not running it properly, it's costing you more in excess equipment and waste and all those things like that. It probably ends up saving money for a facility over time, doesn't it, to get the right equipment?
Some people care about the variable cost, so it's funny. We go into some places and they're like, we're going to invest in the equipment, but we want the cheapest chemistry we can because they're more evaluated on how much they're spending, like a line item on so much. And then some people are the opposite. Like, we don't care much. We're just not going to go spend, $250,000 or $300,000, right? So it really depends on what people are being evaluated on and what they care about. So I see both, but we're working with a big customer now who I told you've got to make it, and they said we're going to, we've got $1 million budgeted for equipment investment. So they see that, they know that. There's actually a lot of good equipment, what I call equipment consultants in the industry that are good at going. Sometimes that's what it takes is I'll have to make a phone call and try to get them together with some of these equipment consultants, because those guys are, they're not selling equipment necessarily. They design and make recommendations, so they need to hear it from somebody else. So sometimes I have to kind of bring somebody else in that can explain what the equipment does, and so that helps. So there's some really good people out in the industry that understand equipment.
Which leads me, as we wrap up here, I wanted to ask kind of a takeaway, big takeaway. For a facility that's looking to start, designing a new cleaning line from scratch, what would be the very smartest first question that they should be asking?
Yeah, what's the future look like? Because one of the biggest problems is people will go specify equipment based on today, right? I got to do this today. The question I should be asking is, what's this going to look like in 5, 10, 15 years? So they don't undersize the equipment, because again, they're trying to spend the least amount of money. But throughput increases unexpected. So I always look at it as you should be anticipating you're going to get more business in the future. It's not going to be status quo. So if you spec your equipment for today, then you could get stuck in 5 years if you do a really good job, whatever your process is. Now you're stuck with equipment that can't handle a higher throughput. So planning, doing a little more planning, what's my future going to look like is the most important thing. And if you have to spend a little more money up front now, that'll pay off in the end. So that's the biggest thing I tell people is, plan to be successful, right? Plan for growth. And that's the big thing with equipment. That's when you get stuck. If you don't plan to grow properly, then you're going to get stuck with a capacity issue, right? And then you're going to call me and say, well, what cleaner can I put in here to make the parts clean faster or clean more parts? And I'm going to say, there's probably not one. It's a throughput problem. So to me, that's the biggest thing is don't be short-sighted. Don't think long-term, not short-term.
Yeah, you won't be having that growth that if you're not planning for it, right? You're definitely not going to have it.
Yeah.
Right. So great. Well, Mike, I appreciate you taking time out talking about this. Hopefully we'll have you on very soon.
Yeah.
Sounds like there's a lot of other topics we could talk about.
Sure. There's lots of things we can talk about. So.
All right. Thank you, sir.
Good to talk to you. Thanks, Jim.
Thank you for joining us. Our goal at Hubbard-Hall is to help you get better results with less chemistry. To hear more stories from the field, go to hubbardhall.com or wherever you stream your podcasts.